Right. Moving on to the mag house install, another fascinating mechanism. These are called spark plugs because they spark and don't behave like a flamethrower. They are mechanically set to create the spark at just the right moment. But when is the right moment? Well, that depends. Theoretically, that should be at TDC, when the piston is at its highest point of travel, so that the max it could compress the mixture present inside the cylinder. But that's not how it's in the real world. The desired right amount is just before that TDC. Why is it like that? Because it takes time to burn the air fuel mixture. Igniting the mixture before the TDC will allow the mixture to fully burn once the piston reaches TDC. Okay, so how much advance before TDC? Well, that depends as well. On what? Quality of fuel, air quality, at what altitude this vehicle is going to be run, which will determine the oxygen present in air, what compression ratio is the engine built to, how it will be written, where do you want the peak performance from it, but most importantly, which idiot is going to tune it. Everyone has a certain preference to their liking. Right. So now that we know what to do, how to do it. You see, when the aliens visited Earth, they told us to put a permanent mark on one side of the crank arm. Crank arm is it? See this part. The piston can go only up and down, but it's connected to the crank by the crank rod. So the piston movement called stroke is converted to the crank's 360-degree travel. What it translates to, that every time the piston reaches its TDC, this fixed point on the crank will be at the same location in its 360-degree travel, and that point can be set to create the spark. How? Because the flywheel has a slot for the woodruff key, which means it will go on the crank in only one way, which means this is relative to the fixed mark on the crank, which is again relative to the piston position inside the cylinder. This we can mark on the housing because it's fixed to the case, and then very cleverly retard or advanced timings on a preference with reference to the TDC on the housing. How do you mark the reference? Timing discs. Sounds simple to you? Sounds genius to me. I'm going to install only the housing now and later set the timings correctly, hopefully. The hardware in here is relatively new and in good condition. Well, I could have replaced everything in that. But why to? Dump as much as grease as possible because this is the only thing it's going to get. Happy with the mess I have made? It's time to install this with the gasket, noting that this extra edge is for the orientation. I have just put the flywheel on to see if the piston movement is good, and these sounds of compression are making me happy. To set the timing properly, let's mark some of the port timings on the Mac housing. Now that this is fixed and this has a 360 rotation, we should be able to mark that on the housing here. Let's see how to do it. The wood key goes only one way to this flywheel. I can use the flywheel itself to rotate the crank, which in turn moves the piston. First, the TDC time, top dead position of the piston. So at TDC, the marking is coming here, which I have to mark on the casing. Moving on to the piston intake. That's where the intake opens. I'm going to mark on the flywheel just like before. At this point, the intake is completely open. See these marks here? This is when the intake begins to open to allow the air fuel mixture inside, and this is when it's completely open. So for this duration, we have the intake. Similarly, you can do the exhaust and the transfer port timings, and knowing your intake timings and exhaust timing and preferably your transfer port timings will help in choosing the right cylinder for your engine for your application, mostly racing or high RPM use cases. But since that's not my goal, I'm just worried about this mark, the TDC. This I'm going to use to mark actually where the engine has to be firing. That I can do once I have the degree wheel. There are specialty tools to find the TDC. How those work is you insert that tool through the spark plug hole, which will not allow the piston to reach its TDC. But since this flywheel can move even with that, this will give you 2 points on this flywheel, which is basically the degree of movement for this flywheel without reaching the TDC. You just have to find the center of those 2 points, which will be actually TDC. I don't have this tool and I don't want to invest in one, so I have done that visually.